Rock the boat, don't rock the boat, baby. Rock the boat, don't tip the boat over. Here's the Earth. All right. And like here's the sun. Far away, kind of. The sun's far. And at about 6:00 p.m., all right, the far side of the Earth is dark. Okay. Yeah. So here's the Earth. All right. And then we'll say this is the center of the Earth. All right. So there is like a path that the Earth takes around the sun. All right. As it revolves around the sun. I guess as it orbits the sun, there's a path that the Earth is on. And then, looking from above, there is a line that is perpendicular to this plane, right? So this path of orbit, this is like looking at the model from above. This orbit represents an elliptical plane that goes through the center of the sun, I presume. So then there's an axis that's perpendicular to that. But the Earth's axis of rotation is not exactly that. That is to say, like the Earth isn't spinning like a top on a table around the sun. Although some of the gyroscopic decay elements are similar to that dynamic. So if I had you can use a coin or you can use a top. I don't have any coins or any tops right now. But anyway, so at about 40 degrees north latitude in the northern hemisphere, and negative 108 degrees latitude. But anyway, it's just mainly about negative 108 degrees latitude. No. 40 degrees north latitude here, and negative 108 degrees longitude. But anyway, negative 40. No. This is like 40 degrees north. Approaching 6:00 p.m. Earth revolving this way. Here's like your Alaska. Here's your like Alberta. All right. Here's your Colorado. There's Colorado, and there's the old Kentucky. So just kidding. But it's spinning this way, and anyway, I didn't draw it right. This wouldn't be 6:00 quite yet. It's about a 4:20. This is about a 4:20 FOCO situation. But anyway, as 4:20 approaches, what'll be going on at the 6:00? 6:00 is gonna be. Here's your Alaska, your Seattles. Here's your Alberta, your Maines. Now as the Colorados. Approaching 6 o'clock. Getting into that. Impulse from northeast to southwest. And so as the world turns, when it's like approaching 6 o'clock p.m., that means your part of the world is starting to have angular momentum away from the sun. See? And right at 6 o'clock, okay, right as the sun's passing the horizon, yes, that's when the tangential vector about that way, is pretty much getting away from center of the sun. So if you were to draw a ray from the center of the sun, okay, if you're going to draw a ray from the center of the sun, okay, out to any of these points, but everything's on the fritz. And the reason everything's on the fritz is, I'll explain a bit more. Let's focus on Earth. Let's focus on Earth, shall we? Let's take a look at the Earth, and we'll consider it this blue ball hurtling through outer space, orbiting around the sun, all the while rotating on an axis. But in terms of shape, we'll consider all of the world's waters, the oceans, the seas, as this blue orb. Fairly spherical in shape, because water has a universal, it has a uniform density, fairly uniform density, and so there's this equal gravitational pull for the spherical body of water. All right, and when measuring Earth, that's very important, because that's why the sailors went out to the oceans. And so a sailor would be out here saying, all right, they left shore right about here. There's a lighthouse. It's about, 1,000 meters tall. And then the ship just set sail pretty much until, due to the curvature of the spherical globe of the ocean, passing of the horizon until the tower was pretty much out of view. And then also knowing something clever, such as the length of a rope that's floating along the water here, and when that rope gets to be taut is when that rope is actually measuring the curvature of the surface of the water all along here. So those measurements are those measurements. We're actually measuring a portion of an arc there, and we're measuring, we already know that the lighthouse here is 1,000 meters tall, and then we're also measuring this distance right here from the tip top of the lighthouse to the observatory here, which is a ship on the ship deck. And so we got those measurements, and now we're in business. It's how we measures. We got them measurements about the curvature of the Earth long ago. All right, thanks to the U.S. Navy, and that went on. All right, thank you very much. So that's how they figured a thing or two about a thing or two. And then that helped them figure even more. And then they got even better at figuring. And now they knew a thing or three about a thing or four. You know what I'm talking about? So anyway, doing some North America. I'm proud to be an American. Anyway, so you got the world right here, North America. Maybe everything's proportional, maybe I don't know. Maybe almost either. So I'll ask you about that later. And so you got the global network, and you know, this is like your negative 100 degree. Maybe that's about negative 100 degrees longitude. All right, negative 100 degrees long. Are you with me? Is that a pretty decent picture? Alrighty. And then just opposite that, on the other sides of the world, is plus 80 degrees longitude. And the way you can always figure that difference is you want to do 180 minus the absolute value of whatever longitudinal value you have is going to yield the opposite, the inverse. For example, right here across the Northern American continent, the negative 100 degree line of longitude runs up here all the way to the pole, and then on the other side, that's positive 80 degrees longitude. All right. And then if we're going to finish up with something like that, this is considered differently when it comes, and latitude is different, believe you me. And that's like this. And that's at plus 40 approximately. All right. And the opposite, finding the other side of what's going on, is going to be at negative 40. All right. And that's going to be some here below the equator. All right. And if you were to extend a line through those 2 points, from this segment to this segment is equal to, like, you know, from North Pole to South Pole. So what I was describing is a process where, and there's an app for this, I imagine. And it's for calculating for given longitudinal and latitudinal coordinates for any given point to calculate what's on the complete opposite side of the world then. So, if longitudinal coordinate is negative 108, a latitudinal coordinate is 39, almosty, not far. Then the opposite of that is, like I said, take 180 minus the absolute value of whatever the longitudinal value you have there. So 180 minus 108 yields 72. All right, that's positive 72. And the opposite of latitude is just, take your okay. The opposite of longitude here, once again, is 180 minus the absolute value of whatever longitudinal value you have. All right? And to get the opposite for your latitudinal values, you get -1 multiplied by whatever latitudinal value you have, okay? So 39 multiplied by -1 is -39. All right. So that's how that goes. And this is somewhere like south of the Indian Ocean, on the other side, out there. So imagine we had like a piston. Imagine if we had like a 2-ton weight and it was oscillating back and forth seas. All right, oriented. It has impulses going from the northeast to the southwest, in like a pendulum motion, periodic motion, like a 2-ton weight, with that orientation at that location at that time. And so that's just interaction. Let's a bit further is, let's say that there's some kind of interaction with a nearby node, okay, and we got nodes all over. All right, let's say. And those are like all right, so there's like this network going on, and now it looks all confuzzled, but what we're getting to is, like, let's consider the position of, if we're introducing a new element to the network, and let's consider that it was, I'll change colors here to make this contrast a bit more evident, but let's just say that, that's somewhere near a pre-existing node, and then there's 2 other nodes placed, and it's like, quite usually triangulating. Or maybe it represents like how they equally divided the sphere best they could. And then that brings me to my next point about CERN and the placement of these circular torque engines. All right, they have the gyroscopic tweaks here and there. But yeah, and then there's a radio relay, and they're just like, I think they're essentially giant centrifuges. Okay? That have a radio relay network. And I imagine so. But the purpose of which is for geostability issues, I imagine. So That was fun.